Hello and welcome again as we consider yet another multiple choice question for IB Chemistry. The electronegativities of four elements are given in the table, and here you have the four elements W, X, Y, and Z and their electronegativities 0.9, 1.1, 3.4, and 4.0. This question is focused specifically on topic 4 of the IB Chemistry Guide, bonding, where students learn that electronegativity refers to the tendency of an atom to keep electrons toward itself in a covalent bond. Here we have an electronegativity of 4.0, and it's very possible that students might be quite familiar with the table of electronegativities, and you would realize that 4.0 actually corresponds to fluorine. Fluorine, of course, is the most electronegative element in the periodic table. Just taking a sketch of the periodic table and its layout, the most electronegative element over here, fluorine, the least electronegative down here at the bottom of group 1. So these non-metals here in group 7, the halogens, very electronegative. Oxygen, very electronegative. Fluorine, very electronegative. And nitrogen, very electronegative. And then metal species like lithium and sodium, potassium and cesium, very low electronegativity. So what we have here is W is likely to be a metal of some kind. You don't have to know what specific metal it is. Y could be something like oxygen or nitrogen. And X could possibly be a metal located maybe somewhere over here. And a rule of thumb is that if the difference in electronegativity between two species is greater than 2, then they could possibly engage in ionic bonding, which is gain and loss of electrons. If it's less than 2, then they are likely to engage in covalent bonding. So this question here is based on that understanding. Which statement is correct? W and X form an ionic compound? Well, W is 0.9 and X is 1.1. Both very close to each other in electronegativities, so the chances of them engaging in an ionic compound is non-existent because it's 0.2 is way smaller than the 2 value that we seek for the difference in electronegativity that would exist between the two members of an ionic bond, like sodium and chlorine, for example. The difference in electronegativity there greater than 2. Here it's just 0.2, so not a possible choice. W and X form a covalent bond. Now, based on the perspective that they have an electronegativity difference of just 0.2, but with these low electronegativities, it means that they are going to be metals, and metals do not engage in covalent bonding, so we need to eliminate B. C, Y and Z form an ionic bond. Now, Y and Z, for a similar reason to B, they are going to be located up here on the non-metal side of the periodic table because they have these high electronegativities, which are typical of non-metals. So they won't engage in ionic bonding because two non-metals will not engage in ionic bonding. And by a process of elimination, we've come to the answer of D, which says Y and Z, Y 3.4, Z 4.0 form a covalent bond. Now, the difference here is just 0.6. That is possible in a covalent bond. And these two are non-metals. So a pair of non-metals, a small difference in electronegativity, and it confirms that a covalent bond is possible. So the answer for this question is D.